For lesson 6-1, we're going to be checking for a proportion. The word proportion or proportional means that two ratios are equal, like 1/2 is equal to 4/8 is equal to 6/12. So when we see fractions that don't have any decimals in them at all, we will just simplify each ratio in order to compare them. So 4/2, we can divide both top and bottom by 2 to get 2/1, and 12/6, we can divide both top and bottom by 6 to get 2/1, so we can say yes, they are proportional. Alright, so again, 4/2, we can divide by 2 again, similar to the last one, so we'll get 2/1, and here we can divide both by 8 to again get 2/1, and so yes, they are proportional. Okay, and this equal sign in between, we want to say equal to, because again, remember, proportional means that they are equal. Alright, so 4/6, we can divide both by 2 to get 2/3, and this one is 2/3. We don't have to simplify at all, so we just say yes, they are proportional. Okay, so it just so happened that all of our examples here ended up being proportional. Let's say, for example, we had one that was 4/6 and let's say 2/5. Okay, well, we would divide this by 2 on the top and the bottom to get 2/3, and that would be equal to 2/5. But obviously that's not equal, so we draw a line through it to show that they're not equal, and then you can just write no. Okay, so that would be the process. If we end up with two ratios that are not equal, we just say no. Okay, now for when we do have decimals involved, you see how I wrote here, we're going to solve it as a unit rate. So a unit rate means we need to go ahead and divide by whatever the denominator is. So here we're going to take 2.7 or divide by 2 to get 1.35. I'll just write that here, 1.35. We're going to see if that is equal to our other ratio, 10.8 divided by 8. And that does equal 1.35. So we can say yes. Okay, so it'd be a little bit more difficult here to simplify these because they do have decimals in them. So when we see decimals, you can just go ahead and divide. And that gets it into a unit rate, because this would be, divided by 2, it'd be over 1. You could actually do that with these as well. We could see that 4 divided by 6 equals 0.6 repeating. 2 divided by 3 equals 0.6 repeating. But I would prefer it if they are just fractions like this. I would prefer you to simplify them rather than just dividing. All right, let's try another one. So we'll go with 11.1 divided by 13, and that equals 0.8538. And I would like you to, for your homework, you need to copy this down. I would like you to show me the decimal that you're getting, and I know this one was a lot bigger than that. The number seems to go on for quite a while here, but you can stop at a certain point and just kind of drop the rest off so we can compare them. All right, so the next one here is going to be, we can clear this out. We'll go with 3.7 divided by 2.6. And we get 1.423. So we can write 1.423. So I know those numbers were a lot bigger than that, but you see we have enough that we can compare them. So I'm going to go ahead and draw my line through and write no. So this means they are not equal, and then we can write no over here, not proportional, because that's what the question is asking. All right, let's try another one here. We'll go with 9.9 divided by 20. So that's 0.495. They are short. You can go ahead and include all the numbers, but if they fill up the screen and keep going, you can go ahead and stop. 2.3 divided by 4 is 0.825, and obviously those are not equal. All right. So those are your examples for today. If you're given fractions like this, I want you to simplify each ratio and then compare them to see if they are equal or not. If they're not, just draw a line through and say no. If they do give us decimals like this, you can just divide both 2.7 divided by 2, and then we'll get a decimal value for, we call that a unit rate. And you can compare those to see if they're equal, either yes or no.